All right, welcome to the next section. Before we begin, though, in this lecture, let's take a look at some devices first, okay? Because this lecture deals with an overview of LANs, all right? And we're going to talk about cabling and things of that nature, half duplex, full duplex, all that. So I want you to get first an understanding of the devices that we use on the network, okay? And how they get connected. All right, now you see here we have routers, switches, router and a switch, router and a wireless router. We have a switch and a hub and a hub, a router and a PC, a switch and a PC, a hub and a PC, and a bridge and a PC. All right. The rule when you're connecting similar devices, you use a crossover cable. None of these are configured, so if some of you are wondering, hey, why do they have red dots? That shouldn't be your concern. They have red dots because they're not configured. That's not what I'm trying to show you. I'm trying to show you is the type of cabling. All right, this is a crossover cable. All right, when we get to the cabling section, you'll understand what I'm talking about. They're using two different standards on either end. Okay, what's going on here? Okay. They're using two standards. You know, we have the 568A and the 568B. Okay, so they're using two separate standards on either side in order for them to connect due to the pinouts, the transmit and receive. All right, I was going to say transceive. I'm trying to mix it. All right, when you have two switches connected together, you also have a crossover cable. All right. You may be wondering, well, hey, how come the switches have green lights? Again, that's not nothing you need to be worried about. But just so you know, switches don't need any configurations to work. You can plug them into the wall, not do anything to it, and you're up and running. Okay. Router to switch, straight through. These are not similar devices. So for devices that are not they're not similar to each other, okay, you will use the same standard, either 568A on both ends or 568B on both ends. Router to wireless router, crossover cable. It's a router, so the pinouts are similar. Now, in the majority of cases, especially in the SOHO world, really the SOHO world where you do have a home office, those routers you purchase at these stores, all right, you need a straight through cable that you can plug into an actual switch if you wanted to, okay? Not a crossover. But if you are going to do it to another router, it would have to be a crossover, okay? Then we have the switch to a hub, similar pinouts. We use a crossover cable, hub to hub, obviously, similar device, crossover cable. Then we have a PC to a router, crossover cable. Laz, are you crazy? How can this be similar devices? It is due to the pinouts. It is due to the pinouts on the NIC card, all right, and on the port on the actual router that they make it similar devices. Whether this be a laptop, a PC, a server, it will have to be a crossover cable. Then we have the PC to switch, straight through, PC to hub, straight through, and PC to bridge, straight through. Now that you're getting an idea that all these devices is what we use in the network, also, we never use a hub. You need to learn about a hub, but we don't use a hub. All right? Since we are talking about Ethernet, and the term Ethernet refers to a family of LAN standards that together define what? The physical and data link layers of the world's most popular wired LAN technology, okay? So when we're talking about hubs, that was something from the past, okay, that we had no choice. The reason we don't use hubs anymore is because it is a shared collision domain, meaning that every time you plug something in, you're sharing that bandwidth with the other devices. So even if you have category 5 cabling, UTP, 100 megabits per second, you're not going to get it. you're not going to get it because the more people you plug in, the less. Let's make it simple math. 4 people connected to a hub at 100 megabits per second, we have what? We have 25 megabits per second per person because you're sharing that bandwidth. Okay? So hubs are not used anymore. And not only that, it's a first come, first serve. So they're all trying to get to, so you can send their message out first. And that's why you have tremendous collisions in a hub. Chaos happens in a hub. We don't use hubs no more. Bridges, we don't use them anymore either. Wired bridges. Wireless is a whole nother story. Wired bridges, no, don't use it no more. They were for the purpose of segmentation. Segmentation, okay? But they were limited to the number of ports, and they were software based, okay? So for that reason, we don't use bridges anymore. So what do we use? Switches, where is it? Switches and routers. Switches, we can create security, we can create VLANs. It's hardware based using ASICs technology, ASICs chips, okay? You can do many things. You can VLANs, everything. The switches is what we use. It could be a layer 2 switch or layer 3 switch. We'll get into that, all right? And of course, the router. The router is the one that's king, right? He's the one that takes the packet and sends it wherever it needs to go. All right, so with a hub, you have one collision domain, one broadcast domain, period. End of discussion. That's what it is. On a switch, by default, you have one collision domain. I'm sorry, that's incorrect. Multiple collision domains, because each port is its own collision domain, but you still have one broadcast domain unless you create VLANs. VLANs will create other broadcast domains. I'm not going to get too much into detail about that, but you need to know this because of the type of devices that you're going to have on your network. Routers by default, each network is its own collision broadcast domain because each port on a router is a different network. Okay? So if you wanted to do that on a switch, you would need to create VLANs. All right, and the reason we create VLANs, what? Security, better administration, more bandwidth for the user. Because I don't care what people tell you. Oh, no, a switch, it already learns. The switch learned our source MAC address. It knows it. There's no more broadcast. Yes, there is. Do this test. Image something. Send something out, a large packet on one VLAN. Right? If your network is on VLAN 1, everybody in there, I dare you to send a huge packet. Huge. Watch your network go, all right? The bandwidth come down because everybody's listening to that noise. All right, so that's the problem. You know what's the quickest way to bring down a network is? Put a straight through cable, okay, into let's say the switch on one port and then to another port, okay? That creates what? A loop. It will bring your entire network down. But if you're VLAN'd out, that may be a different story. So create VLANs. That's the moral of the story. All right, so now you got this. We have collision domains, broadcast domains. We don't use hubs. We don't use bridges. What we use are switches and routers, right? And that's what we need to focus in. That's what we need to focus in. Now, the standards defined by the IEEE define what? The cabling, the connectors, protocol rules, and everything else that is required to create an Ethernet LAN. So what we're going to do now, we're going to look at a typical small office, home office LAN. So let me get that lab out. Where's my mouse? Okay, and there it is, right there. Okay, I think you can see that. Zoom in a little bit more. All right. Oh yeah, you can see that. All right, so what do we have here? We have the 192.168.1.0. It has plugged into that particular port. That's one network, okay? One network. And then we have the 192.168.2.0. That's another network. So we have two broadcast domains. How many collision domains? Well, We have 1, 2, 3, 4, 5. We have 5 collision domains, okay? 5 collision domains and 2 broadcast domains. And a typical small office, home office, you will have, I'm using an access point, and I'm mimicking a real router that I'm actually using, okay, to get out to wherever I need to go. All right, but this is an actual access point. All right, so this wireless printer, this wireless laptop, and they can communicate with each other. They can communicate with each other. I'll go ahead and I'll show you. I'll go ahead and ping. Let me go ahead and ping. This is the, let me put it this way so you can see. This is the 1.0 network. Yes, it is. All right, and I'll ping my gateway, which is ping 192.168.1.254. Okay, I can ping that. I can ping the .2, and the printer, I believe, is the .3. Okay, and I haven't pinged the printer yet. It's made enough on the laptop. I should be able to ping the printer. Why am I not pinging the printer? I got the gateway. Oh, because they didn't put it. 192. Or it disappeared. 192.168.1.3. Let's put that in there and tab that out. 255. Here we go. Close that. And I forgot where I was. I'll just go back to the PC. And let's ping the printer. 192.168.1.3. And I can ping the printer. So we do have connectivity in our own network. And if I were to ping across, which is a 2.1, which is our server, and then the interfaces here, which would be our gateways, 2.254, 1.254 will be able to ping. Why? Because you're connected directly. And I'll just prove it to you real quick just by showing you the routing table. Showing you the routing table. Okay? You can see that, right? Sure. Okay. All right, so I'm going to say enable and then show IP route. And you'll learn all this stuff later. Okay? 192.168.1.0, 192.168.2.0, that's the networks that I'm connected to. All right, and you do a show IP in brief. Oops, show IP int brief. Okay, it shows you that we are up. Okay, so we are connected to those. So Soho LANs in the past may have used hubs. Unfortunately, that's all they had. And if they were lucky enough, they may have had a bridge or maybe even a switch. Obviously, they had to connect to these nodes or end devices to the networking devices using what? Cables. Now, let me stop here. All right, let me close this out of the way. Now, you can see that this access point is connected through a wired cable, and these are not wired. These are actually connected wirelessly. So it doesn't matter what type of medium you have, and we'll talk about that in a second. No, whatever media you have does not matter. That data link is not going to change. So we're going to discuss that in a little bit. All right, because I don't want you to get confused when you read your books. All right, so you can see some are wired, some are not, but they should still perform the same thing. All right, so in today's LANs, today's Sohos, they combine the router and the switch. Okay, vendors that exist out there, they'll sell a consumer a type of router that's integrated with networking devices, and we know that for a fact. We go to our local store and we buy a router. That's a router. They say wireless router, 54 megabits per second. We go all this nice fancy jargon, but what it is a router slash switch. That's what it's doing. The ports on the bottom act as a switch you can connect other devices to, and then the other part is a router because it does routing for it. I don't recommend it. I mean, for a home, it doesn't really matter. For business, small business, yes, you do that. But definitely for business, you want to get into the business grade wireless routers. I don't want to mention names, but whatever you buy at these local stores that you're purchasing, they're really not for large, because the definition of enterprise is that you have your local area network and your wide area network. So everybody has a local area network and a wide area network. If you have one PC, you connect to the switch and you connect to the internet, or what? You have an enterprise? No, you do not. When we discuss enterprises, we mean larger networks. So today, Soho LANs now use wireless technology. Believe it or not, okay? Everybody uses wireless technology to connect to devices as well, whether it be proprietary equipment or have a separate segment for guest users. These devices could be arranged for just simple access to point to wireless routers. Now, this is a small office, home office. Actually, you're working from home, or a very small office that you can say that will have some sort of setup like this. Now, you see that has this router by default, this particular router has 2 fast Ethernet ports, so I can connect 2 switches to it. Some routers may not. All right, and if you do want to segment the network, that means you need to create VLANs. But this is what the book more or less talks about, but I went a little step further as usual and gave you a little bit more of information. All right, so again, access point, and there's a difference. There's no routing going on here. There's no routing going on here. This is Soho. This is just access. What it is, it's an access point from wireless to a wired. That's it. All right, let me show you now an enterprise. What an enterprise network may look like. Okay. All right. So we have wireless devices. We have wired devices, which are our PCs. We have 3 separate networks, right, connected to these 3 switches. And then we have a core switch, and then it goes to the router. Now, normally, they would run a backbone, what's considered a backbone, all right, in between these floors, because I named this floor 1, floor 2, floor 3. I'll show you the configuration in a second. All right, floor 1, floor 2, floor 3. 192.168, 1.0, 2.0, 3.0. Next time you go on vacation, go take a look at the computers that you're using, right? They give you free wireless access. Go to your command prompt, do an IP config, see what your network is. I guarantee you it has something to do with your floor. That's how they arrange it. It's either 200 or 100 or 300. It can't be 300, but it'll give you some sort of idea that they're using the floors as their networks, okay? And see if you even have the actual devices, which when I went overseas, I did see the actual routing devices in the room, which is not very good. You don't want that, okay? Normally, what typical enterprise LANs, right? Their networks, they have similar needs, they really do, as Soho networks, but on a much, much larger scale. To begin with, okay, these networks are placed in a wiring closet. What are they called? They used to use this terminology back in the day. I don't know why they still don't use it now. They do, I don't know. They're called MDFs, which is main distribution facility, and IDF, which is intermediate distribution facilities, right? Your MDF was your main closet. That's where your main servers and switches, core switches, and everything that you had in there, firewalls, were there. That was your point of presence. That was your POP, okay? So that's where your MDFs were. Then every other floor was your IDF, So most enterprises also support wireless LANs to allow users to do what? And this is kind of funny because it's true, right? They allow you wireless access throughout wherever you go, so you don't leave the building. Even when you go to lunch, right? You're eating at the cafeteria, you can still be doing your work. All right, they don't want you going anywhere. Okay, they don't want you going anywhere. So definitely, this is what an enterprise network would look like, but they would have a backbone going up these 3 floors. Okay, not just connected to that, because there is no redundancy here whatsoever. There's a very basic setup. Okay, and you have something called Ether channel that will be going up, or you'll be running fiber going up, or you'll be running coax going up. It all depends what it is that you're using. But let's go to the presentation real quick. Now that you've seen what a small office and home office is and an enterprise LAN, that wasn't too difficult. What we're going to do in the next lecture is we're going to start talking about cabling. I'll see you in the next one.